Hey everyone, my name is Ajay and this is a part one, cloud computing. In this session, we are going to learn about what is cloud computing. So there's a funny image on my screen which you can see, and a lot of computers they are flying towards the plane. Is there something called the cloud computing? Probably not. So we are going to learn how cloud computing touches our life on day-to-day basis and what it means for us. So let's get started. If you ever prepared a network diagram, you might have created or shown the internet connectivity. So these kind of symbols you might have used. So the name cloud computing was inspired by the cloud symbol that's often used to represent the internet in flowcharts or maybe on the diagrams. Let's talk about how it touches our day-to-day life. So let's assume you have some sort of the app which is installed maybe on your desktop, maybe on your mobile device. For example, YouTube. So the moment you started using the YouTube to watch any sort of the video, all the data, all the videos, it comes from somewhere. Most probably they are hosted on your cloud platform, which is true in case of the YouTube. Let's talk about emails. You might have apps installed on your mobile device, or maybe you're using the Gmail. All this data, it cannot be stored on your mobile. So probably there are some servers sitting in some data center. In this case, it is going to be the Google Cloud Services. Very similarly, we are carrying our phone, and most of the time, there's some permission you need to grant so Google can track your locations. So all the tracking of your data, it goes to cloud. Similarly, you want to store your pictures, images, videos on the Google Drive, maybe on the OneDrive. All that data is getting stored on cloud. Maybe you're a fan of the playing games. Very similar. You will have some sort of console which connects you to cloud platform, and you play the games. As we know, whenever we touches the cloud, there's going to be some sort of the data transfer between your end equipment and your cloud service provider data centers. So let's talk about what are data centers. So technically, a data center houses your servers, your storage, and your networking. There are enterprise who runs their data center by their own. Those are sometimes referred as on-prem or on-premises. When we talk about the cloud service provider, it can be the combination of 100 or maybe 200 data centers. Those are offered to the customer. And the services we call those cloud services basically. So typically in a data center, you can host 10 of servers, maybe 100 of servers. And when we talk about the cloud data centers, so these companies like Amazon, Microsoft, they're offering you the public cloud computing services. And these data centers are hosted across the globe. Before we get deeper into the data center subject, let's take a look on some of the stats available. So my left hand side, this is a data center data traffic pattern from 2010 to 2024, and it is in zettabytes. We are almost here. So within the next 3 years, it is expected to reach 150, which is going to be almost double. Similarly, this is the traffic and this is the number in millions of users from 2010 to 2025, and this is also rapidly growing. Ashburn is a city located somewhere on 34 miles from the Washington, D.C., is widely known as data center capital. So what are the key contributory factors why this traffic is growing? So as we know, the number of users are growing, and since our cloud computing and the data center traffic, it touches our day-to-day life. So the way the number of users are growing, the data center traffic will grow as well. There's also a key contributory factor here I see during the COVID-19 pandemic, also known as coronavirus pandemic. Between February and April, at the peak of worldwide lockdowns, global internet traffic surged by nearly 40%, which is driven by video conferences, online gaming, streaming, and social media. In India all alone, OTT and voice and video traffic, it grew by 1300% during COVID, and same time the gaming also rose by 1000%. Now we understand the need of data center hosting facilities and the internet bandwidth with ever-growing internet users. So let's talk about the data centers first. As I mentioned earlier, a data center is a secured space housing your compute, storage, and networking. So technically, a data center will consist of your IT equipments like servers, networking equipment such as router and switches, and your storage arrays. There is a city called Ashburn in Virginia, which is 34 miles from the Washington, D.C., is widely known as data center capital of the world. So why everybody is running behind the data centers? Let's talk about Facebook, let's talk about Microsoft, or maybe Amazon. Every now and then we hear in news that they're opening a new facility. So data centers are not all about doing the virtualization. Data centers is all about proximity. Your rating will go up, depends on how close you are to the users. So a typical data center facility looks like this. You're going to have a big space and you're going to host a lot of servers inside, networking, storage. There are some innovations also. The moment you open the data center, the additional things you need to count, it is going to house your cooling, ventilation systems, power backup, security, fire protection, and definitely you are going to have the monitoring for all these elements as well. So let's talk about some of the innovations now. So innovation comes with challenges. Let's assume you have a server which is running 24 across 7. It is going to consume a lot of energy. Compared to one server in a data center, you might have millions of servers. So think about a need for energy. So there is a study which was done which tells you Global data centers use roughly 3% of total electricity generated worldwide. That's huge. Same way, data center also consumes a lot of water, which is directly used for the cooling. So you're going to have the air conditioning, you are going to use the power, and there are a lot many things. So for example, there is a very good chance you are playing or watching a video, which is a streaming video, and if you watch it 2.5 hours HD video with live streaming, it is going to consume somewhere around 1 kilowatt hours of the energy. And and nowadays, since everybody is moving for the 4K ultra high definition streaming, so this consumption is going to be threefold. You might end up consumption of the electricity which is going to be around 3 kilowatt hour. So there are a lot of things involved. It all contributes to carbon footprint. And there are also some triggers like GDPR. If you follow the GDPR policy, your data center, your data actually should not leave the boundary of the country. So you also need to follow the rule and regulation of that particular country. So that's one trigger for opening a data center. When you talk about cloud computing, your your user experience is going to be based on your proximity. So everybody wants to come closer to the users. That's another reason for opening the data centers. And there's a third trigger. I might be belongs to the banking sector, and I feel my data might not be secured on the cloud infrastructure. That's the way I'm going to open my private data center as well. So let's talk about the innovations now. It can be a typical data center. And there's another way you can classify the data center. It can be the green data center. So what makes it green? So I already talked about the carbon footprint. So maybe here you going to use different methods to make your electricity consumption more efficient. So you reduce your carbon footprint. Maybe here I rely, so maybe my right hand data center, it is sourced from some, which is something, a power generation, which is something based on coal, maybe gas, maybe on oil. On my left hand side, this is data center is sourced from the renewable energy, which might be coming from the windmills. Similarly, there was a project which was offered by Microsoft, that's NATIC. So in the NATIC, why do I need to open a data center? And the reason behind the moment I decide I will be opening a data center, I need to build a lot of infrastructure. I need to ensure I get proper energy, which is sourced from the renewable energy. I need a lot of water, which is again going to be have some sort of the impact on the environment. So why not to create something like a capsule? In this capsule, you might have all the storage, networking, everything, all the compute units, and drop it near to sea, I mean under sea, basically. All the energy which comes from the renewable energy, and your cooling is taken care by the water which is available on the sea. We already talked about the data centers. Now, not every data center is equal. So there's some classification that is based on some sort of the standard available in the market. So there are going to be 5 types of tiers. So tier 1, tier 2, tier 3, 4, and the fifth is the latest one. So when we talk about these tiers, what are the differences? So it is basically a difference when it comes to your service provider, what kind of the service level agreement you might have. So in the tier 1, you can see the uptime for the services are going to be 99.671. Similarly, higher the tier, higher the SLA. Let's talk about the tier 5. So tier 5 is something new, and the SLA committed by the service provider is going to be the almost same. The only difference in the tier 5 you are going to see, can you run the data center for 24 hours without the water? You also need to have some sort of the prediction. Have you seen a kind of the flooding in this area for last 100 years? So these tiers basically, it depends what kind of power backup you have, how can you sustain in case of the disaster. Let's talk about a typical data center network, how it looks like. So in a typical data center network and those secure facilities, you are going to have the server racks. Those server racks will also host some sort of the switch. It might be from Cisco, it might come from Juniper, Arista. There are a lot of vendors who provides you the switching gears, switches and router basically. And in a typical data center, you might have a lot of racks. This is the first, second, third, fourth. The number of racks, it depends how much space you have. And the space within the data center facility, it is based on the number of tiles. Those switches will be connecting to your routers. If you have redundancy, you will have multiple routers hosted in the data center. So that's the first level of redundancy. You are going to have a WAN connectivity so that users from, or maybe your customers from outside world, they can access your services. So you might have connectivity to some other cloud service provider. You might have connectivity to your internet service providers. You might have connectivity to your partners. Maybe they are giving you some sort of the POP connectivity. So this connectivity is very important. And when we talk about the cloud service provider, your proximity also, the proximity and the connectivity also depends how many peerings you have and on what level. More peerings, more connectivity to internet exchange, it gives your user a better proximity. You might have heard about the term called bare metal or maybe the commodity servers. So let's try to discuss and explore what is called a bare metal versus commodity server. So all the service providers, basically they are having kind of the shared infrastructure. So instead of they go for a very high-end supercomputer model, what they have chosen a term called clustering. Here you combine all the servers and top of that you run a hypervisor which manages all the resource what you get from the servers. So what is the major difference versus the dedicated servers available in the market? It's basically the cost and the purpose. Bare metals are cheap hardware which can give you the same performance. So basically, you have some standard specification. Those are given to your hardware vendor, and they produce some sort of commodity servers. And in a cluster, all these servers can run all together and give you some supercompute power. What we need to consider basically here, these hardwares, if there's some sort of the failure, it should be easy to replace and it should be reliable as well. For example, Google search cluster compute, it uses 15,000 nodes in a cluster. That's a lot. They might have gone for a supercomputer kind of stuff. That also works, but that's going to be very, very costly. So instead of going for a high-end compute system, you go for the commodity-based servers. Those are cheaper, and you put those all servers into a cluster to get the same performance what you get from the supercomputer model. So let's take an example. There are a need for having high CPUs because whenever the customer comes and they go for some sort of the VM compute, you need to dedicate some sort of the CPU, RAM, etc. So here let's talk about the number of a typical commodity server, how much RAM it can provide you. So on my screen you can see they normally comes with 16 or maybe 24 slots. If you go for RDIMM, 16 into 32 GB, so it gives you 512 GB total RAM capacity. If you go for LRDIMM, which is going to be 16 into 128 GB, it gives you around 2 TB. Same way, if these commodity servers have 24 DIMM slots, if you go for 24 into 32 GB, so each RAM which you put here is going to be 34 GB. That gives you the total capacity of 768 GB per server. Very similar way, if you fill all these 24 slots with 128 GB of RAM, it gives you 3 terabyte of the capacity. Let's now talk about the open network gears. This is the same concept which is applicable to servers. When we were talking about the servers, we discussed about the bare metal servers and the commodity servers. So your networking infrastructure is also something based on the commodity. For example, Microsoft developed a OS which is called Sonic. You can run this Sonic on Arista, maybe on the Juniper, on the Dell switches, maybe on the Cisco switches. So what you need a standard hardware and this OS can be deployed. Very similar fashion, Facebook introduced six-pack switch. The data center operated by Facebook, they are based on this hardware. So it's again the same concept. It's a cheaper hardware which is open for industry. You can run the OS. Earlier, it was like a concept. You go and buy a Dell switch, or maybe you are buying a switch from Cisco. It is going to be the operating system which is developed by these vendors. So now with this open networking hardware, you do not have any such dependency on the code. Now let's talk about the merchant silicon. With the growth of the data center and the number of internet users, there's also need of the high speed. So this hardware sitting in the data center where we do the routing and switching also evolved. So on my screen, you can see in 2010, Broadcom developed a chip which is called Trident, and the capacity for the ports were around 10 gig. In 12, they launched Trident 2, capacity become 40 G. And 14, they launched 100 gig. Then some architectural change. We more and more servers you add, more interfaces you need. So they doubled the interface from 32 to 64. And in 2019, they were talking about 400 gig capacity. That's huge. A term which is called merchant silicon is basically the same chipset. It can be used with most of the vendors. So you might find if you go and purchase the switches, you might find it's the same chipset which is being used with most of the vendors. So Juniper, IBM, Alcatel, HP, Arista, Dell, even Cisco, they are based on the merchant silicon, and same chipset can be used with most of the switches in the models. Depends what kind of capacity you want to buy, whether you want to go for 10 gig or you want to go for the 400 gig. On my screen, you can see this is a typical compute hardware it looks like. So you have a racks and you need to put lot many similar units like this. Let's talk about the cluster networking now. We have already learned that in cloud computing, you are going to combine lot many commodity servers. So for example, in this diagram, you can see I might have the two racks. My one rack is filled with 6 servers. My second rack is also filled with 5 servers. And all these servers, they are connected to the switch infrastructure. So technically, there's a networking in between. Earlier, if it is a, let's assume this is a standalone. So I can be limited to the capacity of that server. Now, since we are talking about a big single computer, and that's technically going to be a combination of the servers. All this is called cluster. So in a cluster, you might have, it depends upon you, what is the capacity you want for that particular cluster. It will also depend on your hypervisor, what kind of hypervisor you uses. So if you go for a hypervisor from ESX, earlier the capacity with ESX 3.5, it was around 32 hosts. So in a cluster, you can add maximum 32 hosts. With new version, you can see the capacity rose and now you can add 64 such servers in one cluster. Very similar concept with the Hyper-V. If you are on the Windows 2016, you can add max host, which is going to be 64. If you are on Windows 2008 R2, you can add max number of hosts, which is going to be 16. With 2012 also, the 64 is valid. I'm just giving you an example when we talk about the virtualization, how we build the clusters basically. In a cloud environment, it is going to be the specialized hypervisor where you might end up adding maybe more than 1,000 nodes. Let's now talk about the cluster benefits. So we built the cluster. This is rack 1. You have these many nodes. In the rack 2, you have these many nodes. Similarly, you might be having a number of racks in your data center. And these physical nodes, which you can see here. On top of the rack, you are going to have these switches installed. So all cablings are within the rack. So what benefit basically we get out of it? First of all, it is going to provide you the high availability. What it mean by high availability here? So let's assume this is a compute unit. You are running your virtual machine maybe on this node, and suddenly you see this fails, this hardware fails. What will happen? There's some monitoring happening. This VM immediately come up on a different host maybe and boots from here. So your resources are always available, no matter how many failures you see in this cluster. In the hypervisor term, you can say as if you talk about the VMware word as a vMotion. My hardware fails and my VM smoothly moves to another physical host. Second, it is going to be providing you the load balancing. Load balancing means this is a cluster. So this is a big computer, which is a combination of 100 of the nodes. If the request comes, you will be able to handle those many requests. So it is a kind of the distribution. For example, maybe you are running a cluster for your gaming purpose. You might see someday millions of requests are coming. If they are going to one server, probably that server won't be sufficient or will not have the capacity to handle million of the requests. So there has to be a kind of the distribution. And when we talk about the cluster computing, all those requests will get distributed to all these nodes. Now let's talk about the scaling. You can very well do the scaling here. It depends. Maybe today I'm a startup, so I start with one rack. Tomorrow I need to add another rack. So you can keep on adding these racks. So cluster size, it will depend on your requirement, and when the requirement grows, you can keep adding those compute nodes. Performance, as we spoke earlier also. So performance, it depends upon what kind of hardware you have within your server. Earlier, everybody was talking about the supercomputer model. So what is supercomputer model? You are going to have very high-end CPU, very high-end RAM, and all the resources are available to do a very fast compute. It's the same concept here, though it's a cheaper hardware, but you have a combination. So earlier, one server was serving you and giving you the performance. Now there are 1000 nodes. They want to give you the same performance. Cost. So commodity server, as I explained earlier, it is all about the cost. If you go for the supercomputer, it might cost you very high. If you go for a clustering model, the cost will come down and you get the same benefit. We already talked about compute hardware, networking infrastructure. Now there's a third component, which is storage. So we all know it. Since we are going to do some sort of the computing and you need the storage devices where you are going to store your data, your images, your video, your streaming stuff. Since we are discussing the cloud scale, there's going to be a huge demand of storage. If we go for a previous or legacy kind of the data center, there was always a need of storage. And we typically call it SAN. So to establish a SAN, basically what you needed is specialized NIC cards on your server side. Those are basically the HBA. Then you are going to have fiber channel switches, and then you are going to have the array. Those might be coming from the NetApp or maybe some other vendors. SAN was very reliable. We all know it, but it's very, very expensive as well. In a cloud scale data center, what we need is cheaper hardware. It's a very similar concept of commodity servers, or maybe just a merchant silicons. So here you can see a typical storage hardware looks like this. You can put a lot of hard disk. Those can be your old STDs, and you can also install SDD. That is going to be the much faster. Or you can have the combination of both. So there's a term called JBOD. It's just a bunch of disk. So you have many disks installed in a JBOD, and the capacity can scale up to the petabyte per hardware device. It is a sequential. So it start filling your data. Once this disk is full, it moves to the new disk. When this disk is full, it moves to the new one. So there are high chances this disk can be filled. If this disk can be filled, what will happen to my data? Answer is pretty straightforward. If the disk fails, your data is lost. Then the question might come in the mind, if I'm going to lose my data on the cloud, why should I opt for the services? And that's a very genuine question as well. So here, they are going to secure your data while doing the duplication. You might have 3 copies of your data in one data center. If you go for the geo replication, maybe it is going to have another 3 copies. So when you lost this data, or when you lose this data, your data can be recovered from different storage. Now let's talk about the hypervisor, which is going to be the fourth component. And this is a kind of the software which basically you install on top of your hardware. So there are 2 types of the hypervisors available in the market. One is going to be the type 1 hypervisor. So let's assume this is your hardware, your RAM, your CPU, everything is here. Top of that, you install a hypervisor, which is a kind of the software which helps you to virtualize the hardware basically. And top of that, this is going to be the guest OS. You might be running your Windows operating system, you might be running Linux operating system, and they both are going to share the resources from your same hardware. There is another type of hypervisor which is also available. So let's assume you have a hardware. Top of that, you might be running a native OS, which is going to be Windows. And then you are going to install a kind of the hypervisor. And then on top of that, you are going to install your guest OS. Again, all these VMs, they are going to utilize the resources from your hardware. On hypervisor type 1, this is basically used to do the virtualization on the server side. So you might be running a data center, you will have a lot of nodes, and when you create a cluster, everything is managed by your hypervisor, and on top of that, you are running your services in terms of the VMs. So there are very few famous hypervisor type 1 available in the market. You can go for the OpenStack, you can go for Zen, it comes from Citrix. You can go for Windows, it comes from the Microsoft. You can go for the KVM, it comes from the Linux. And you can go for ESXi or vSphere, that comes from the VMware. In hypervisor type 2, maybe you're running a Windows operating system, and that can be the workstation. You can download this piece of the software from these websites. So this is a VirtualBox. It's a product of Oracle. You can go for VMware workstation. You can go for virtual PC, and you can also go for the Red Hat. So since you're already running a kind of the workstation, and top of that, if you want to install a guest OS, these softwares can be used. Cloud computing is all about your proximity. Closer you are to the user, better the performance is going to be. So you can look at my screen. This is Azure Global Presence. They have data centers. You might call it a region. So they opened all these data centers for all these locations. Very similar way, this is the presence of AWS. They also call it regions. So you can see these regions. So they also opened a lot many data centers, and the only theme is the proximity. Very similar theme. Google also opened data center in the same fashion. We talked about the data centers and all these data centers, how they talk to each other, how they connect to the user. So most of our internet is carried over the submarine connectivity. On my screen, you can see all these cables. They are the submarine cables under sea. All of our internet traffic travels on top of that. These are owned by some of the providers. Now there's a race which is going on between the cloud providers. Let's talk about, I would not say the cloud provider, it can be the right term can be the content provider. Let's talk about Facebook, let's talk about Microsoft. So as of today, Microsoft owns largest piece of submarine connectivity. Then you have the Google, you have the Amazon. Submarine cable investment. So this race is all about who is owning the content and who is owning the connectivity. If I own the content and I also own the connectivity, then I can rule the world. So look at my screen, you can see some major investment. These investments are coming from Microsoft, Facebook, Google, and this announcement 15th May 2020, Facebook to build internet cable circumferences of Earth. That's big one. Let's talk about the data center interconnect now. So maybe within a region, you might have multiple data centers owned by you. How these data centers connects to each other. So there's a term called dark fiber. All of our data center connectivity from each other, most of the time it happens over the dark fiber network. So in fiber optic networks, when data being transmitted, light is passed through the cables. If there is no data being transported, there are no lights waves traveling along the cable. Therefore, we call it a dark fiber. For example, let's assume I have a data center facility, data center 1, data center 2, data center 3. And these all three data center, they are owned by some service provider. They are going to talk to each other over the DWDM network. That is going to be the data center connectivity. All this dark fiber connectivity started from 10 gig, then it moved to 100 gig, it moved to then 400 gig with enhancement bought by the coherent technology. This is already tested and in production. Now they are talking about a connectivity of 800. That is also going to be the huge one over the same dark fiber infrastructure. Then these data center, they are going to connect to colos. These colos, POPs are nothing but the facilities of it can be the Econex, it can be Cologix, it can be any other vendor. I might have some sort of the connectivity from these vendors, maybe from Econex, that's the most famous one. And I want to use the Azure services. So from customer point, I will be connecting to this colo, and they colos are further going to have a dedicated connection between these data center providers. So data center to data center, it is all over the dark fiber. Then there's going to be a ISP peering. ISP peering, there are tier 1, tier 2, tier 3, and tier 4 ISPs. All this peering has to happen. All this network has to talk to each other. So they are going to do the peering at multiple locations. Those can be the POPs, those can be the data center, and you are going to connect to each other. Then let's assume this is a enterprise network of one of the organization. You have some sort of the connectivity from tier 2 ISP. This tier 2 ISP will further have the connectivity to tier 1, and this tier 1 will be connecting to your colo, and colo is going to talk to your data center to get the content. There's another way also to access the internet, which is going to be from satellite. So on these images are the teleport. They can talk to satellites, transponders, and they might have some sort of the fiber connectivity to different locations. There are some famous service provider, Earthling, Hughes. They are going to give you a communication way to communicate to the satellite. You might be installed a dish antenna on the roof of your office, maybe home, and you can access all these services over the satellite. Now let's talk about the cloud services. What are the cloud services? How many offerings you get from your service provider? So the first one is on-prem. On-prem means this data center is fully operated by you. So you are going to manage your application, you are going to manage your data, you are going to manage runtime, middleware, operating system, virtualization, server, storage, and networking. It's an end-to-end your CapEx and OpEx. When we talk about a cloud service provider infrastructure, you can divide into IaaS, it is going to be infrastructure as a service. So application, data, runtime, middleware, and operating system is something which you are going to manage, and your underlay virtualization, servers, storage, networking, that will be taken care by your service provider. Very similar way, the other offering is PaaS, which is platform as a service. Here you are only going to manage your application and data. Rest of the services will be managed by your service provider. You are not going to have any sort of visibility into. Then the third offering is going to be SaaS, which is going to be software as services. So everything is managed by your service provider. Now let's talk about some of the past examples. Salesforce offering your platform. Oracle is also offering your platform. Then you have AWS Lambda, you have SaaS given as a platform as a service, Google Compute Engine, Work Express, and there are many more. Now let's talk about the SaaS examples. It is Dropbox, Jira, SAP, Salesforce, and many more. Thank you everyone for watching. I will see you in the next video.